Okay, so what we're going to do is we're just going to go through basically all of the tests that we did a couple weeks ago, the released EOC, and just talk about some things. You have an IXL assignment tonight and tomorrow night. They're both already posted. It's 25 questions each day. Okay, so that's what the expectation is. They're due Wednesday by 8 o'clock. 8 a.m. Yes. You have the EOC on Wednesday at 8:30, so they're due Wednesday morning. Yes. Where are you going to be tomorrow? In the morning? What?
Is the EOC like an all-day thing?
Very likely. It'll take you a minimum of 2 hours to get done, but some people it takes 4 to 5 hours. Okay, it'll be, the EOC is around 50 questions, multiple choice, slash fill in the blank, slash multi-select, blah, blah, blah. But then there's also a performance event. Sometimes it's one question, sometimes it's multiple questions. But when it's one question, there are multiple parts to that one question. So sometimes you'll have one question that has like 3 parts to it. Sometimes you'll have 3 questions that have 3 parts to them, or 5 questions that have 3 parts to them. It just depends. Okay? So on this first one, there should be very little thinking involved here. How do I know where the solutions to any system is when I look at the graph, Derek? Where the 2 lines meet. So they meet here and here. So I should have 410 and 7.75. So C should be my answer. Okay. On this one, which of the following are factors of the equation when written in factored form? Okay. So we're going to move this over. Okay, so for me to do this in factored form, I don't want it to look like it does right now. I want it to be a trinomial, right? So I want to set the whole thing equal to 0. How can I set it equal to 0? I can't factor anything yet. I need to set it equal to 0. What do I do? Get A by itself. No, that won't work. Set it equal to 0. Come on. I need to set one side equal to 0, and that's the right side. How do I get the right side equal to 0?
Put 0 equals 3.
No. No. Huh? I don't have any parentheses, so there's nothing to distribute. How do I move this 3A? I subtract it. That's what I'm doing, guys. So I have 2A squared plus 5A minus 15. Now, equals negative 3. Now what? Add 3. That's going to give me a 0 over here. That's what I wanted. Everybody with me on that? So I have 2A squared plus 5A minus 12 equals 0. So now I can factor this, or if you were just solving it, you could use the quadratic equation, right? But in this case, we want to factor it because I want to know which of these could be a factor of this, all right? So if I have a lead coefficient other than 1, in this case I do, that's a 2, right? What do I have to do?
Divide by 2 for each of them?
No. I'm factoring here. You guys are making me really nervous.
Yeah, you factor A out of...
Do you remember that? A times the absolute value of C. So it's going to be 2 times what? 12 times the absolute value of negative 12. So 2 times 12 is 24. Now I need to do what with 24? Right, so I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Since I'm multiplying to get a negative, my signs here must be what? They got to be opposite, so a positive and a negative. So how can I end up with a positive 5? Positive 8, negative 3. Do we agree with that? Okay, so now that I know what my two values are, what am I going to do with them? I wanted this term to be split. So I have 2a squared minus 3a plus 8a minus 12 equals 0. I did this because I haven't changed the value. If I take negative 3a plus 8a, I get back to 5a, right? So, what can I do now? Right, I can factor by grouping. So I'm going to group these two. I'm going to group these two. What can I take out of both of these? No, I can't take a 2 out. I can take an a out, leaving me with? Okay, what can I take out of here? A 4, a positive 4, right? Leaving me with? 2a, because I'm dividing. 8 divided by 4 is 2. And then what's this? Give me minus 3 equals 0. Now what? Right. These are the same, so I can factor them both out. So when I do that, I have 2a minus 3. And what else? A plus 4 equals 0. So what are my answers here? Right. So on this one, it says select all that apply, right? So A, nope, not A. B and D. Everybody with me on that? When it says select all that apply on your EOC, there will be more than one answer. Okay? Whoops, wrong thing. All right, so back to the Pear Deck. So on this one, it says Kelly recorded the amount of money she earned for Y hours, earned Y for hours worked X in the table shown. Select the words that correctly complete the sentences. I'm going to give you 30 seconds. Go. Have this going. So looking at your answers, I feel like we can agree that for the most part it's increasing and it's linear, right? So the way that I can tell it's increasing is by looking as X increases, what does Y do? They're both increasing, so that means it's an increasing function. If as X increases, Y was decreasing, it would be a decreasing function. Okay, so it's increasing. The reason that it's linear, who can tell me why? I saw a good example. Somebody had written some other extra things on theirs. Right. Right. So if I take X times 15, I have that constant slope, right? That constant rate of change. That's what makes it linear. 1 times 15 gives me 15. 3 times 15 gives me 45. 4 times 15 gives me 60, right? Head up, sir. Thanks. So the last part is this y-intercept, and we were kind of 50-50 on that. I had about half of us who said 115 and the other half that said 0, 0. I want you to think about the y-intercept. Okay, so if I graph this thing, I had 115, I had 345, I had 460, right? So it looks kind of like this. Is 115 the y-intercept? No. Okay, the y-intercept is where x is equal to what? 0. Okay, so on my x-axis, I have to be at 0 to hit the y-axis. Do you see what I'm saying? So it has to be 0, 0. All right. The table shows the distances that schools will travel to attend a field trip to the state capital. School 7, that's hard for me to say together for some reason, has to travel 15 miles. If this outlier is added to the data, which is a true statement about how it changes the data in the table, select all statements that apply. Okay, so we have to select all that apply. So again, I'm gonna give you 60 seconds this time. Go. You still have to take, yeah, you have to take the EOC on Wednesday.
We're gonna have to do 25 during class, all 25 during the day today.
Okay, so on this one, first of all, we have data is more spread, both the mean and the median change. Data is more spread, they both change. Data is more spread, they both change. Same thing, same thing. Whoever this is, it can't be less spread and more spread at the same time, so no. Those are opposites. When it says select all that apply, whoever this is only one response. There is more than one response. Okay? So, looking at the options, you know you have to pick one of these two. It's either less spread or it's more spread. And adding 15 to these numbers is clearly going to make it what? More spread. Okay? So it has to be B. Both of them changing, I would say that probably happens too. There's no change to the median and the mean. There's no change to the spread. The median stays the same, the mean changes. Yeah, I don't. Just for good measure, did anybody actually find the mean or the median? Nobody actually found it, you just guessed? No. Ooh, okay, so whenever you do the EOC, you need to actually do it, okay? You need to determine what the actual mean and what the actual median is, because if you just guess, you are so setting yourself up for failure. So I would guess that they both change, but for good measure, I'm going to check it because I want to be sure, okay? So we already said that it's going to be more spread. We know that. To find the median, I put them in order, right? So I'm going to start with 15. What comes next?
15, 150,
150, 200, 380, 380, 400, 425. So the median is the middle number, right? Okay, so without that number, I'm going to do that in red. So if that wasn't there, I would have 1 off the front, off the back, off the front. So then I have 2 of them, right? And it's the same. So I add them divided by 2, gets me 380 for that median. Now, with the 15, I would go off the front, off the back, off the front, off the back. So it leaves me with this one, which is also 380, which means that they do not both change. Okay? You have to check it. So the median stays the same. So that means that it is either it's either D or it's F. Well, I'm just going to tell you, there's no way the mean doesn't change when you add that really small number in there. But again, for good measure, we should try it. So if we put 15 in here with it, when I add all of these up, what do I get? Click, click, click. Everyone has a calculator. Kevin, that means you too. You have a calculator. Add them up. Okay, so we have a 1,550 and 1,950. You got 950 also, or 52? Also. So 1,950. And what am I going to do with this value? Divided by 7. So what's that give me? 278.5. Now I want to do it without the 15. So that means I can just take this number and subtract 15 from it. So I have 1935 divided by 6, because there's one less value. What's that equal? 322. So did that change? Yes. So that means the answer has to be F. So your answer here should have been B and F. Okay. Whoops. Wrong thing. All right. Moving on. On this one, solve for B sub 1. So for this, the first thing that we should do is what?
Get B1 by itself.
How could I do it?
You have to
So B1, let's just, for the fun of it, B1 is right here. So what would I do?
you have to what's it called? Distribute the 1/2.
I don't have to do that.
No?
I don't have to. I can move it to the other side without doing that and deal with less fractions that way. So if I'm multiplying by 1/2 by all of this, the opposite would be to what?
To divide.
To divide by 1/2, which is the same as multiplying by its reciprocal, right? Everybody agree with that? So this cancels with this. So now I have 2a equals b1, the quantity of b1 plus b2 times h. What should I do next? Divide by h because it's being multiplied by this whole side. So those now cancel. So I have, oh yeah, okay. I have 2a over h equals the quantity of b1 plus b2. What should I do now?
Plus.
No, you're right. Subtract b2 from both sides. So those cancel. So my answer is 2a over h minus b sub 2 is equal to b sub 1. So our answer on this one would be what? B. Okay. All right. The area in square units of a rectangle is represented by 6x to the third minus 2x squared plus 4x. If the width in units is 2x, what is the length in units? Enter the expression as a length in units in the box. So let's just move this over. All right, so on this, they're telling me that I have a rectangle. They're telling me that the area is equal to 6x to the third minus 2x squared plus 4x, and that the width is 2x. They want to know what the length is. Okay? How do I find the area of a rectangle? Length times width. That's right. So that means that 6x to the third minus 2x squared plus 4 equals L times this 2x, whatever the length is. You agree with that? So to get L by itself, what would I have to do? Divide by W. I divide by this 2x. When I divide by 2x, that's the same as factoring. If I take 2x out of all of this, what am I left with?
2x would be 3x cubed
Squared.
Squared minus 2x.
Mm.
1x.
Minus x. Yep.
Plus 2.
Oops, there was supposed to be an x here.
Plus 2.
Plus 2. This is my answer. That's it.
Wait, that's an x there then. Oh, yeah.
No, it came out. So 3x squared minus x plus 2, that is my final answer. Everybody with me on that? Uh-huh. Okay, I'm going to give you 30 seconds. Go. So this person says that we should multiply the exponents and get 1/12. This person also says 1/12. This person says 7/12 because they should be added. Joe is correct. They should be added. They say multiply. They say add. They say add. Man, we're like half and half on whether we should add or multiply these things. So my question to you is, whenever we multiply by the same base, what do I do to the exponents? You add them.
And if there's a divide, you subtract.
That's correct. When I multiply by the same base, I add the exponents. When I divide by the same base, I subtract the exponents. When I have a power raised to a power, what do I do then? Multiply them. Okay, so these are my rules. If I have I'm multiplying by the same base, That is, I add the exponents. If I'm dividing by the same base, that means I should subtract the exponents. And if I have a power raised to a power, I multiply the exponents. Does everybody understand what I'm saying on that? Got to know those rules, folks. Okay, I'm going to give you about 15 seconds. Go. Okay, so we have quadratic formula, factoring, quadratic formula, quadratic formula, quadratic formula, factor, quadratic formula. Okay, so it's definitely one of those two. Those are the only two responses that you should possibly have. Gentlemen, I'm not going to talk over you, thanks. So whenever you look at this, if it's factoring, that means you should be able to factor it easily. So what multiplies to get a positive 3 and adds to get a positive 2? What is it? What multiplies to get 3?
Negative 1 and 2.
Okay, so if I have a negative 1 and a positive 2, if I multiply negative 1 times positive 2, do I get a positive 3? No, if nothing comes up, it's not factoring, which means it must be the quadratic formula. Okay, so C should have been your correct answer there. Select ordered pairs that satisfy this function. Select all that apply. That means there's going to be more than one answer. I'm giving you 60 seconds. Go. Okay, so what did you do to solve this one? What did you do to figure out your answers? You put it in the calculator, and what did you put in the calculator? The function. Okay, and so you graphed it? Okay, so what did that do for you? It gave you a line. So did that help you come up with these values?
Yeah.
It did?
Yeah.
How?
2 of them.
2 of them? Okay, so a more surefire way is to, you can go to the table from there. So if you go to the table, you can look at all of them. Sometimes there are going to be values that maybe are harder to find on your table. So if you know how to graph it and go to table, so graph it and go to second graph, and it'll take you to a table of values. So in your graphing calculator, if we go to y equals, the function is negative x squared, and then plus 2, graph. So it comes up with this, not a line, it should be a parabola, right? And it's, why is it opening downward? We could have known that. How could we have known? The negative was in front with that x for the coefficient. So then we go second graph gives us this table. So I have negative 1, 1. That's my A that was on there, right? So negative, so A is an answer. B is not an answer. C, they say negative 2, which is what we have. So we should have A, B. And then for D, they say 2, negative 2, which is an answer. So we should have A, C, D, and then the last one, they have negative 2, 2, which is not an answer. Okay, so our answers on this one should have been A, C, and D. Very good, whoever this is. You almost got it. No. Okay, A, C, and D. So another way that you could have done that, if you don't remember how to get around in your calculator, anybody have another method? You can just plug them in. This is X, and this is Y, all the way through here. So if I plug in negative 1 for X, f of negative 1 is equal to negative 1 squared plus 2. So negative 1 squared is, no. Negative 1 squared. What's negative 1 times negative 1? 1. Bring down your negative plus 2. So what's negative 1 plus 2? 1. So that means this is an answer. This one is therefore not an answer. I could plug in negative 2. F of negative 2. I have negative 2 squared plus 2. What's negative 2 squared? 4. Bring down your negative plus 2. What's this give me? Negative 2. So C is an answer, which means E is not an answer. So the last value I have to check is positive 2. So what's positive 2 squared? 4. Bring down my negative. Bring down my positive 2. What's this give me? Negative 2, which is what I have here. So A, C, and D. Okay, residual. The residual value, pay attention because we haven't talked about this in our textbook. And we haven't talked about it on IXL either. The residual value is how close every point comes to falling on a straight line. So, if it is in the positive direction, and the points are really close to the line, that gives you a value of positive 1. So if all of the points fall exactly on a straight line that has a positive slope, the residual value is 1. If it's a negative slope and they all fall on the line, it's negative 1. But these do not all fall on the line. First of all, this should be easy. Go ahead and answer this quickly. Which one matches the best? Quick, quick, quick. I have 5 of 7. Who are the other 2? Let's go, let's go. Quick, quick, quick. All right. So, we say D, 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 D. Okay, whoever this is, this line in no way represents this data. I couldn't say that the data falls along this line, so this is not correct. It is D because we can see it's positive, it's going in the upward direction, it kind of falls in the middle of the data. That is our best option. So whoever this is, no. Okay. Further, I gave you some additional examples here of residual values. So this one here, that is, the line here is very close to these points. Would you agree with that? This probably has a residual value of like 0.8. If they all fell directly on the line, it would be positive 1. So the closer it is to falling on a single line, the closer the value is to 1. So this one would be close to what?
1.
Not negative 1 because it's going down. See what I'm saying? Now this one, it is spread out, but you can see that it has a positive correlation, right?
Yeah.
So this is probably like a 0.6. Do you see what I'm saying? And then this one would be, right, okay, so the farther they are from the line, so if they're just scattered all over the place, so for example, if you had a graph that looked like, you had a graph that looked like this, and there's nothing that tells you whether you have you can't tell if there's a positive or a negative correlation there, right? That's 0 because there's no correlation. Do you see what I'm saying? Are you with me on that? Okay. This is the question that we left off in my last hour, so this is where we're going to pick up. So, wants to know which of these equations the ordered pairs are solutions of. It could be neither. It could be both. It could be just one of them. But every row has to have an x. Every row has to have at least one x, if not 2. So I'm going to give you about 2 minutes here to work on this. 2 minutes. So there are a couple of different methods that you could use to do this. Somebody tell me what you are doing, because I'll follow whichever one you're using. Okay, so I have graphing, and I plug them in. So you graph them on your calculator? On paper? Okay, I would use your calculator if I were you. But you can just plug them in. Is that what everybody else did, was plug in? Okay, so this is what my first group said they had, but we haven't checked any of those yet, so we're going to check them now. So if I plug in -5, 0, this is my x, this is my y, all the way through, right? So I'm going to say -2 times -5 plus 5 times 0 equals 10. What's -2 times -5? Negative times negative? 10. Plus 5 times 0 is 0 equals 10. Oops, I put a 15. Is this true? Yes, so this is the solution here. On this one, I have 0 is equal to 2 times 3 raised to the -5th power. Plug this into your calculator. Okay, turn it on. You need to go to, plug it in, because everyone, I should hear your clicking because you're doing it yourselves. 2 parenthesis 3 close parenthesis caret, and then yours, I don't know if it opens a window for you or not, but parenthesis -5, close it up. Enter. Is my answer 0? No, it would round to 0 if I was rounding to 1 decimal place, right? But it is not equal to 0. So that means it is not a solution here. Okay. On this one, same exact process. I'm going to plug in -2 times 0 plus 5 times -5 equals 10. So this gives me 0 plus this gives me -25 equals 10. Is that true? No, so this is not a solution. If I plug it in here, I have -5 equals 2 times 3 raised to the power of 0. What is anything raised to the power of 0 equal to? No! 1. Anything raised to the power of 0 is equal to 1. Just a little refresher on that. So if I plug in 2 parenthesis 3, close it up, raise it to the power of 0, my answer is 2, because this is the same as saying 1 times 2. Is 2, whoops, pen, come on. Is 2 equal to -5? No, so my x for this one should be neither. With me on that? Next one, I have -2 times 0 plus 5 times 2 equals 10. -2 times 0 is 0 plus 5 times 2 is 10. Is that equal to 10? So I should have an x here. Okay, next one, I have 2 equals 2 times 3 to the power of 0. We should know from this last one, is this going to be true or false? What did we get whenever we plugged that in? We got a 2, so it's true. Because 3 to the 0 is equal to 1 times 2. 1 times 2 is 2, right? So I should have a mark there as well. Okay, last one. I have -2 times 1 plus 5 times 6 equals 10. So what's -2 times 1? -2 plus 30 equals 10. Is -2 plus 30 equal to 10? What's it equal to? 28. So that's not part of it. And finally, I have 6 equals 2 times 3 to the first power. What's 3 to the first? 3 times 1, or excuse me, times 2 is 6. So is that part of it?
Yeah.
Yes. So I shouldn't have an X here. I shouldn't have an X here. I shouldn't have an X here. So my solutions, where they work, the first ordered pair works for the first equation. The second ordered pair doesn't work for either. The third ordered pair works for both. And the last ordered pair works for the second one. Everybody with me on that? All right, moving on. Okay, a police department captured 30 speeds on radar and organized their data in the box plot shown. What can be inferred from the data? Select all that apply. I didn't give you the option to edit this, did I? Okay, so we'll just talk about it. So it says select all that apply. First of all, on the EOC, anytime that it says select all that apply, there is more than one answer. There is at least 2 minimum. They could all be correct. When I went to an item writing conference, it was for MAP. It wasn't for the EOC, but on MAP they were talking about changing it to select 3 correct answers or select 4 correct. So you knew. I don't think that they made that change on your EOC, at least not at that time. It's been a couple years. I was hoping that that change would occur, but I don't know if it did or not. Okay, so you just know if it says all that apply, there is more than one. There is definitely more than one. So the mean is equal to the median. Can I determine that by looking at a box and whisker plot? No, I cannot. The mean is probably less than 30. Can I determine that? How? How can I do it? I can't find the mean because I don't know the data. However, these, let me move this over so I can write on it. Okay. Each of these little segments here, this is the first quadrant, second quartile, third, and the fourth. What you know about this is that, what you know about each of these is that they have the same number of data points in each quartile. You see what I'm saying? Yeah. Okay, so I have the same number of data points here as I do here, as I do here, as I do here. They're all equal to each other. With me on that? Yeah. So, does it look like, based on that, that it would be more than or less than the mean? I said the wrong thing, didn't I? What did I say? Oh, I have the answers over here. Sorry. Okay, so less than 30 miles per hour. The mean is the mean. We said we can't tell if it's equal to because we can't actually determine the mean. But is the mean probably less than 30 based on this information? Yeah. Yes. Yeah, because you have lower numbers, these really low numbers. You see what I'm saying? Yes. These numbers are all pretty closely grouped together. That's what you can tell by this. But you have these lower numbers out here that's going to bring it down. So I would say yes, it's probably less than 30, which means that the mean is probably not more than 30, right? Yep. And then an officer captures an additional speed of 70 miles per hour. The mean must change. So if I had 70 miles an hour, which would be 60, 70 all the way out here, would the mean change if I included that in my data set? Yeah. Yes, it's going to raise it, okay, because you're adding it in and you're dividing by the number of numbers. Does that make sense? A really big or a really small outlier affects your mean. So D is correct. And then if an officer captures an additional speed of 70 miles per hour, the median must change. That one is no, and if you watch the beginning part of this video, you'll see an example of that. But you could have 5 30s in a row here. One number won't necessarily make the median different if you have the same data value being repeated. Does that make sense? So your answers here are just B and D. Okay, so on this, I just wanted to give you an example of some box and whisker plots and talk about some different things with them. So first of all, what would you say about the minimum value for both of these box and whisker plots?
50.
But there's no value on here. But what could you say without any numbers being on here? What could you say?
First one has a greater mean.
Median, maybe? You probably could say, well, we better not. Okay, so greater median for both of them, for the second one than the first one. Is that what you said? The second one has a greater median? Okay, so you could say that because it's at a higher point. But what could you say about the minimum value? It's the same. What would you say about the maximum value? How are they different? I need more than that. It changes. How? Be specific. What's different about these two? The second one has a higher max value. Okay, the interquartile range. Which one has a bigger IQR? What? The bottom one. Do you remember what the IQR is? IQR is the interquartile range. It is Q3 minus Q1. That's right. And looking at this, this is Q3, this is Q1. Q3, Q1. Do you see what I'm saying? Yeah? All right. Just wanted to go over some details. So minimum value, Q1, median, otherwise known as Q3, or excuse me, Q2, Q3, and then your max value. Okay? All right. The next thing that we're talking about is completing the square. Oh my God. All right. So completing the square. We have talked about this, but I wanted to go over what it was before the next question because we didn't do a lot with completing the square, but we did enough that you should remember and be able to use it. So if you're completing the square and they give you this equation in this format, what you want to do is move the c, that constant term, over to the other side. So that's why it says minus c over here, because we subtracted c from both sides. Are you with me at how we got from here to here? Okay, so the next thing that we do when you complete the square is you take half of b, so b over 2, you square it and you add it to both sides. Okay, so completing the square, we take half of b, we square it, and we add it to both sides of the equal sign. We don't do this until we have ax squared plus bx by itself. So we had to move this plus c. Everybody with me on that? So on this one, which equation completes the square to create an equivalent to x squared plus 10x plus 13 equals 0 in the form of x minus p squared equals q. So I'm going to give you 2 minutes to figure this out. Go. Time's up. So on this one, first of all, there's a quick way to determine which answers you can eliminate by looking at your plus and your minuses here. Okay? When you take half of b, this is obviously b, right? A, B, C, with me? When you take half of b, is this a positive or a negative? Positive. So when I take positive 10 divided by 2, what's that going to give me?
Positive.
A positive, which means A is not an answer, D is not an answer. It has to be B or C. So right now, without doing any work, you have a 50-50 chance of guessing it correct, right? Even if you're not really sure, you got a 50-50 chance. Now, the only other thing that's different between these two is the 12 or the 25. First of all, where does the 25 come from? 5 squared, right? That half of b squared is 25. Why might it be 12 instead of 25? What's the first thing you should have done on this? Move the 13. When I move the 13, what did it become? Negative. So it was negative 13 plus 25 gives you positive 12. So B is your correct answer there. Let's see how we did. I got a B, a D, a C. I don't know what this means. That's a B? Okay. B and a D. All right. So a couple of us, those of you that chose D, I hope you understand why it would be a positive instead. So that just gives you that 50-50 chance of guessing the correct answer just by looking at that sign. All right, next. Which of the equations are represented by the graph shown? Select all that apply. I'm going to give you another 2 minutes. And go. Okay, time is up. Are you all right? Time is up. Log those answers. Some of you, I have them now, I think. Lock your screens. All right, let's see what we've got. Can't be A, can't be D, or B. Looks like we guessed D, maybe. Oh, I see. No. Okay, I don't see. So this person says it is A, B, and D. So maybe that was what you were what you were trying to say here. A and B, D only, A, B, and D, E only. All right. Well, let me see here. This is number 14. The answer is A, B, and D. Okay? So whenever you're doing this, all you have to be able to do is use your calculator and look at it, right? So y equals, clear this out. Type it in exactly the way that you read it. X minus 2, closed quantity, new quantity. X minus 4. Whoa, too many minuses. 4. When I graph it, looks exactly the same, right? Goes through 2, 0. Goes through 4, 0. Next. Clear it out. I have x minus 3, closed quantity. Square it. And then plus 1. Graph it. Ooh, oh, I didn't type it in correctly. Okay, here's an example of you needing to be careful. I didn't put my exponent in parentheses, so it took all of it. Do you see what I'm saying? So whenever you do this, whatever your exponent is, in parentheses, and then plus 1. Oh, whoops. That's what my problem is. Sorry. Oh, I was looking at this one.
I did that wrong too. That's why I only picked the 1.
Okay. And then, so you saw on that last one, though, whenever I typed it in correctly, so we have a negative and a positive whenever I was looking at the wrong one. You saw that it didn't go through there, so that's how you know. It should look exactly the same, and they give you points that it goes through. Okay? All right. The graph of a linear equation is shown. What equation represents the graph shown? And then on this one, you'd have to type in your answer. But I didn't give you the option to type anything. We're going to talk about it together here.
It's a negative.
You just be quiet. A negative what?
Huh?
A negative what?
It's a negative trend.
It is a negative trend.
What I tell you.
But we wouldn't say a negative trend. We would say it has a negative slope.
Yeah, that's what it is.
Yeah, it is. Okay, so on this one, if I'm wanting to write the linear equation for this line, what format am I using? What formula? Y equals mx plus b. So I know it's going to be y equals a negative because Axel just said my slope was negative. So negative something x plus whatever my b is. So what is my b? I should be able to determine that very quickly. 5. It's where it goes through the y-axis, right? So that's at 5. It's a positive 5. And then the last thing I have to do is look at my slope. So this is an exact point. The next exact point is what? Down 2, run 3. So we're saying this is the other exact point. So it's a negative 2, run 3, so a negative 2/3. This is my final answer. Okay. Boom. Oops. All right, so the quadratic function f of x is shown in the graph below. If the graph f of x is moved 4 units down, nope, left 4 units, and 2 units down. I can't, my dyslexia, I'm reading out of order, I'm sorry. What would be the equation for the new graph in vertex form? Okay, so in vertex form shouldn't scare you because they're all in the same form here, right? It's just a matter of which one looks the way they want it to. Whoops. So, whenever you're doing this, you should sketch yourself a little visual of what this looks like. Okay, so I want it to move what direction?
4 units.
It's left 4 units and 2 units down. So, from the vertex here, I want to go left 1, 2, 3, 4, down 1, 2. So it should be right here. I'm going to trace this just for the sake of looking good here. So it should look like this. Okay? So, on your own right now, I'm going to give you 60 seconds. Find the equation that looks like this purple one. Go. Is up. So let's look here. Let's see what we've got. D, no. D is the answer there. D. Okay. Good. D is the answer. 17. A car sales business is analyzing the number of cars sold and the average daily high temperature. The data is shown on the graph below. So, we have when the temperature in degrees Fahrenheit is 30, they sold 1. At about 35, they sold 1. 40 was 1. 50, oh no, it's not 1. It's 2. So at 40, they sold 4. At 50, they sold 5 and 7. At 60, they sold 11. At 70, they sold 12 and 13. And at 80, they sold 15. Okay? So, the question is, which statement is correct based on the data? I'm going to give you 60 seconds to read through them. Go. Okay, so I have a C, 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 B, C, and B. Okay? So they want to know which one is true based on the data. So the temperature gives no indication. That's absolutely not true. There's clearly a positive correlation going on here. If the temperature is 50, the amount of car sales will definitely be 4. That would not work because at 50 they sold 5 and 7. The higher temperature is correlated to higher car sales and causes it to increase. And then the last one saying that it doesn't necessarily cause it to increase. So there's obviously a correlation. It's positive. Your answer should be C. All right. Select the graph that shows the solutions to the system of the linear inequality, which is this system right here. So it is y is less than or equal to 2x minus 2. Y is greater than negative 4x plus 4. So I'm going to give you 2 minutes. Go. Okay, we have A, B, A. So we have 1 B and the rest A's. Let's see. Whenever you graph these, first of all, the inequalities, if it has the equal to, what does that mean about the line? Solid. If it doesn't, it is dotted. Is this less than or greater than? Less than. So I would shade below, not to the left, below. And then for this one, I would shade above. Okay, so when I graph this, negative 2 is right here. And from there, where would I go? Up 2, right 1. Up 2, right 1. Okay, so that's not great, but you get the idea.
That would be solid.
It would be solid. We already said that. So it looks about like this. And where would I shade? below it because it's less than, right? So I'm going to shade here, all of this. Okay, so from the get-go, B cannot be it because it's not shaded here. See that? Which means A also can't be it because it's not shaded here. Are you with me on that? So it could be C or it could be D. With me?
Yeah.
Okay, so then the next one, we'll go blue. So whenever I start with this, where I'm going to start graphing at? Positive 4. 1, 2, 3, 4 right here. And from there, where am I going to go? Down 4, right 1. Down 4, which would be about here, right 1. So about this. Okay, so whenever I draw my line through that one, it needs to be a dotted line. And it needs to be blue. Okay, so it's going to be about like this. And where would I shade it? On the right side of it? Above or below? Above it. So if I'm on a car and I'm driving on it, I would drive on this side of it, so that's above. So it would be here. So what is my answer? D. So everyone got that one wrong.
No, I think one person chose B.
No, A and B was all that was chosen. All right. Moving on. The following question has 2 parts. First answer part A, then answer part B. Riley needs to save $300 for a computer. She gets an allowance of $10 a week and already has $75. Part A, how many weeks X until Riley will have enough money to buy the computer? Select the correct symbol to model the situation. So, do it. Select the correct one to model the situation. Okay, so on this one, we have less than, we have greater than, we have less than, greater than, less than. So we are split 50-50 on this one. X is the number of weeks, and she has to save $300. So on this one, $300 has to be less than the amount of money that she has saved in that amount of time. Okay, so she's already got 75 times X number of weeks. It's not going to come out evenly. That's why it's not equal to. Okay, so it's going to, if I solve this, let's look at that. If I solve this, let's say we put an equal to in there. So if we say it's equal to, whoa, those are fat. I would subtract 75 from both sides, right? So I get 225 is equal to 10x. Divide by 10, what do I get? 22.5. I can't have a half a week. She only gets her allowance once a week. She's not going to get it midway through the week. She's going to get it once a week. So it has to be that this side is greater than this side, or that 300 is less than what she saved. So our correct answer here is less than. Okay. And the last one, which we just talked about, what is the value that the solution, what is the value that is a solution to the situation in part A? So you should be able to answer that very quickly. Quickly. So we say C. Guys, it's 23.
Oh, you want us to round up?
Yes, we just said she can't have a half a week. It has to be 23. 23 weeks. Supposed to be gone tomorrow. All right. Even if we do not, no. I will go back tomorrow to other parts of this probably, or I may pick specific things. I haven't decided yet. So, question 20. The following function was used to calculate the profit generated by selling t-shirts. Let f of x equals 15x minus 25 represent the profit function, and x represent the number of t-shirts sold. Which statement is true of f of 200? I'm going to give you 60 seconds. Go. So we have D, deleted response, C, D. I'm not sure what this is supposed to be. Torn between the two, perhaps. D, C. So we can't decide which is true, C or D. It's one of the two, it appears. All right, so let's see which it is. If we have f of 200, what does that mean that you need to do? Plug it in. So all you have to do is substitute. So what is 200 times 15? 3,000 minus 25? Okay, so the question, the issue here is, does that mean that's how many t-shirts, or does that mean that it's a profit? Okay, so X represents, what does X represent? The number of t-shirts. X represents that. This is t-shirts. What is this? That's the profit. It is the profit. Okay, the answer should be D, because f of x is the profit. The number of t-shirts sold was the 200. Does everybody understand that? Okay. Be careful about what they're saying to you. All right, so on your own, graph the inequality. I'm going to give you 2 minutes. Do a good job. Go. Okay, let's see what we have now. I have shading above this dotted line with this has a y-intercept of negative 14. I would not agree with that. Y-intercept of negative 3, it looks like, dotted, but it's shaded above, which I wouldn't agree with. Also above. Why are we shading above on these? Anybody? What symbol is this? Less than. This is not pointing a direction, guys. You have to think of it about driving the car. Remember, if I drive a car on this line, I would be driving from left to right. I would drive on top of it, right? So less than, you shade below the line, right? You remember that? Come on, you're better than this. We don't flip it because when we divide, we're dividing by a positive. You should divide, but it's by a positive. Okay, and then it should be up 3 over 5 from there. So dotted line, this is not even close to through negative 3. You need to do better than that. On your EOC, you're going to have to graph on the EOC. You're going to have to do a good job. Okay, you need to be as close to the exact points as possible. Okay, so all of these, you guys are hurting me a lot right now. Iron. This one is not close either. This is at through negative 4 instead of through negative 3. You need to be more specific than this, guys. Oh my gosh, I had one person shade below. No shading, no shading. One person who got this bad boy right. Whoever you are, good job. Killing me. Killing me. Okay. Which of the following represent functions? Select all that apply. I'm going to give you 2 minutes. Go. I don't need this extra crap. Stop it. C, D, E, B, C, D, B, C, D, B, C, D, B, C. Again with the extra crap. I don't want it. C, D, C, D, B, C, D. Okay, so we have some common things, and we have a few that are different. So let's take a look at this. First of all, I can tell whether or not this is or is not by looking at what? input. How many outputs does this one have? This one? This one. That is a problem. Okay? On this one, you can make your own input, output, and test it. So I have -2, -1, 0, 1, and 2. Y is 3. They all go to 3. Is this a function? Is this a function? Yes. How many outputs does this have? This one. That's the requirement. It doesn't matter that they all go to 3. What matters is that they go to exactly 1 output. They all must have exactly 1. Everybody with me on that? So B should be an answer. How do I check C? Vertical line test. So anywhere I drop a vertical line, it can only cross the function 1 time. Does that happen? Yes. So C is a function. D. How do I know that this is a function? What is this? It's slope-intercept form, right? It's a linear equation. That means that it's a function. It's linear. And what about this one? How can I check it? Vertical line test. And what happens? Hits it twice. That means it is not a function. All right. A student graphs f of x equals x squared, then graphs g of x equals x squared plus 5. Select the word that correctly completes the sentence. Go. I have up, 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 up. How can you check this? How do you know if that's what's happening? Juan? You just graphed it. Plug that baby into your calculator. Plug in the first one first, and then plug in the second one. So it'll graph it in that order. So it graphs this one first, which is a parabola that goes through 0, 0. This one is a parabola that goes through what? 0, 5. Everybody with me on that? So it moved up 5 units. All right. On this one, it's kind of hard to see. I don't know what that bottom one says. We have exponential decay, exponential growth, linear, and quadratic. Okay. And so F, G, H, and K is what this one is. So I want you to draw a line from each type of function to the function shown in each table. Okay, so I'm going to give you 2 minutes. Go. All right, so we have that the first one is exponential decay. The next is, no, it's not in order, I lied. The last one is exponential decay. The second to last is exponential growth. F of x is linear. And g of x is quadratic. All right, let's see. Whoa, I hit the wrong button. Sorry about that. Is that the same? Looks like we have some similarities. So let's take a look at this here. Oh, wait. I want the clean sheet. All right. So looking at the first one, f of x. What do we think that this one is? We all think it's linear? How do you know if it's linear? Okay, so what's happening from here to here? Up 1. Here to here? Here to here. Okay, what about here to here? Down 4. Here? Here? Okay. So if I put these over each other, is it going to be a constant rate of change? I have rise over run. Okay, so this is my rise. So I would have -4 over 1. -2 over 1. -1 over 1. Is that the same all the way through there? No. If it was a because whenever we do that, you should have a constant rate there for it to be linear. So instead, you can tell that it's going down, right? So this one should be your exponential decay. Whoa. Do you see what I'm saying on that? Okay, so the next one, what's happening here? 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 What's happening here? Down 2, here? Say the same, here? Up 2. So what's this look like? Huh? It's quadratic because you can see it going up and then back, going down and then back up. Do you see that? So this is quadratic. And then what's happening here? Up 1. What's happening here? Nobody knows. Okay, this is up by how much? A half. What's this one? What's this one? This is the same all the way through. You see that? Now, it doesn't mean that it has to be the same all the way through from the get-go. You might have to reduce, because if it's not by 1, 1, 1 on this side, you might have to reduce it. But since it is, and it's the same, this is the one that's linear. And they give you those fractions in there to scare you and make you think that it's not linear. Okay? What's happening here? What? Up 1 here? Here. And here? Up a half. That's not a half, that's a fourth. Here? A half. Here? So this one is your growth. Exponential growth. Do you see that? Yes? No? You all are confused probably? Yeah? Do you understand how I'm telling whether or not it's linear? Because that's really what you start with, is by looking at your change in y and your change in x. That's what this is, these little things out to the side here. That's change in y over change in x. And you can determine whether or not it's linear. You can find the slope from that. So the slope of this one is 1/2, right? So if I wanted to come up with the equation, I have the slope, I have an ordered pair. All I have to do is plug it into my point slope form and simplify. Okay. All right. Which of the following statements describes the linear model shown? I'm going to give you 60 seconds. A little tip for you all. When it says select all that apply, there is more than one correct answer. Okay? They won't say that if there's not more than one. So if you just chose one correct answer, that's not correct. So D on that one, D. They would not give you full points for that. D and E on that one. D, D. Okay, so on this one, this is number 25, it says a student with a perfect attendance is expected to score approximately 98% on the final. So this is the number of school days missed and their attendance or their percent on the final. So if they have perfect attendance, that looks pretty accurate to me. On the next one, D is what most people were saying. For each day a student is absent, the student's final exam score is expected to decrease approximately 6%. So they're saying that that's basically the slope is 6%. So from here to 1 day, or it says 1 day, right? For each day? Yeah. So for no days missed to 1 day missed, that looks like about a 92. For 1 day missed to 2 day missed, that looks like maybe an 87, so about a 5%. So a 6 is pretty close. So that's correct. The last one, we had some people who chose E. I can't read what it says at the moment. For every 6th day a student is absent, the student's something score is expected to decrease approximately 1%. So they just have the slope backwards on that one. Make sure you're doing it in the order that they say. Okay, so it is 6% for each day that it drops. All right. Compare f of x is equal to x squared minus 2x minus 3, and g of x, this is g of x, and they want you to place a check mark, a dot, whatever you want to, in the columns based on these two things. So this is the function, which you can determine this information however you want to, but it could be for both, it could be for neither, it could be for one or the other. I'm going to give you 2 minutes. Go. And there's also one that applies to both functions. So no. Are we just guessing? No, that one actually looks kind of close. Okay, I'm just going to tell you, whoever these people are that are selecting neither multiple times, very unlikely they're going to do that to you. It's going to work for one or the other. Maybe one of them neither, like I said, and then one of them that is both. So, whenever you are looking at this, and you're trying to determine these things, what would be a good way for you to do that? Any ideas, or what did you do? Nobody knows? Okay, well, first of all, looking at this, determining where zeros are, how can I do that just by looking at this table? How can I determine where zeros are by looking at that table? Say it again. 0 for what? Zero for what? 0 for y. I thought you said it right, but I wasn't sure. Okay, 0 for y. So on this one, for my g of x, the zeros, immediately I can see I have a 0 for y here, I have a 0 for y here. You agree with that? So that's at 1, and that's at 3. So I know it doesn't apply here, and it doesn't apply here. Now, no matter where your minimum's at, where's my minimum at here? Where my -1, that's my lowest y value, right? So my minimum is at -1. Do you see what I'm saying? Does that make sense? Okay, so the -4 doesn't apply. So all of g of x is done just by looking at the table. Does that make sense? Okay, so the next part, for this one, you can actually plug in if you want to. I would probably look at it on my calculator. So if I graph this, it is x squared minus 2x minus 3. So whenever I'm looking at this, first of all, the minimum is not at -1. What's my lowest value here look like? -4. So it looks like that one goes there. Doesn't apply here. My zeros. Who can tell me where my zeros are based on a graph? Anybody? Anybody? Where my zeros are based on the graph? Chandler? It's not the middle. What do you mean the middle, I guess? Not the x and y, only the x-intercept. Where it hits the x-axis are where my zeros are. Okay, so I have one here, and I have one here. So this one is at what? -1. This one is at 3. So at -1 I have a 0. At 3 I have a 0, so it doesn't apply to this one, it doesn't apply to this one. So since it didn't apply to anything at 2, that's the one that's neither. Everybody with me on that? So if you got that right, I think there might have been a couple of you. But everyone's with me on that? Use your calculator, look at that graph. On the other part of it, let's see. On this, you could graph this too. You'll have scratch paper that's blank graph paper. You can have as much graph paper as you want. Plot these points. Plot the ordered pairs and see what you can determine from that. Okay? Look at it any way that you need to look at it. 26. Which table represents linear functions? This we just talked about, right? You should be able to figure this out. Select all that apply. That means there's more than one correct answer. I'm going to give you 2 minutes. All right, so on A, what are we increasing by all the way through? 1 all the way. 1, 1, 1, 1. That means that this number has to be the same all the way through for Y for it to be linear. What are we doing? Down by 3 all the way, right? So this one, yes. B, what are we doing here? Up by 1 all the way. What are we doing here? Okay, so as soon as I see that it's not, this is 1, 1, 1, 1. As soon as it's not the same, can't be B. With me on that? Okay, C, what are we increasing by here? 1 all the way. And for Y? 3. Yeah, 4 makes more sense. 4. 4 all the way through, right? So C is the answer. D, what are we increasing by here? 1 all the way through. What about here? You're dividing by 3, right? Doesn't work. Has to be adding or subtracting. Have a good day. Okay, so 28 says the following question has 2 parts. First answer part A, then part B. So Jonathan is trying to solve this system of equations. It wants you to graph them and then give the solution. So you should have the ability to draw on this. I want you to graph your system, and then you, I think, have a text tool also. Put in your response. You have 2. Okay, your time is up. Whenever you graph this, first of all, they were nice to you and they put it in slope-intercept form. So that is y equals mx plus b. Whenever I start graphing, what do I graph first? B, which is your beginning point. So for this first one, I'm going to start with 3 on the what? Where at on the graph? Y-axis. So 3 is right here. Okay. From there, where am I going to go? -2 over 1. Slope is always what over what? Rise over run, which is y over x. Change in y over change in x. So I'm going to go down 2, run 1 to the right. Whoops. And I want to point out that they've given you this oddly labeled, your scale's different on this, right? So that you're going to make mistakes. They've done that to you on purpose. So down 2 over 1, down 2 over 1. Okay, so I have this line. I
have a question.
I have an answer.
EOC, you want lines have to be perfect?
They need to be as close to perfect as possible, yes. Because what they do is they have, it grades it, or it should grade it automatically, so it has like a little bit of wiggle room based on where it needs to be, but it needs to be really stinking close. So like things you really want to make sure of is that your y-intercept is exactly correct. And they'll give you like you can plot points, and they give you a line tool just like what I have here. And so you want to plot your points like we practice and then put your line through those points. Okay? So that's that one. And the other one, what am I going to start by graphing? -2 on my y. And from there, where am I going to go? Up 1, run 2. I see that I hit this point first thing, right? Up 1, run 2. So I have to graph it. I'm supposed to graph it. So it should be like this-ish. And I can see that they meet right here. What is this ordered pair? 2, negative 1. That is correct.
How do you know that?
Because that's where it is. Let's see. Where's my remote? I'll zoom in for you. Okay, so when I zoom in on this thing,
Oh, that's where they touch.
that's where they touch, so that's the solution. You see that? So I'm over 2, down 1, so it's 2, negative 1. Good? Everybody understands where we got that from?
Yeah.
Wonderful. So let's take a look at your responses here. We just started. That's pretty close. Also pretty close. Oh, that's scary. Okay, so you really have to be careful about, especially when you're graphing on the computer. But you can also, there's nothing that says that the graph on the computer is the only graph that you have to make or that you can make. You're going to have unmarked grid paper. You can graph that baby by hand. You can use your calculator and graph both of them to make sure you get that solution correct. Right, your calculator option. Whenever we graph them on the calculator, remember we just go here, y equals negative 2x plus 3. Right, I know. 1 divided by 2, x minus 2. So you can see what it should look like, right? Now the thing that's deceiving is that this is by 1s and this is by 2s. They do that to make you make a mistake, okay? So you really got to be careful that you're looking at what they actually are. But this gives you an idea of what it should look like, and you can easily tell what the solution is from there, okay? Huh?
Now that I know it's not going to be used like this.
Yes, it will. All right, so on this, I want to go back to something I talked about with other groups today. First of all, it says the following scatter plots show relationships between two variables. Draw a line from the correct correlation coefficient to each graph. So R is the correlation coefficient, and these are the values. And the way that you determine this, what the values are, okay, we talked about this earlier today. The closer that the points are to falling on a straight line, okay, let me back up. First of all, correlation matters for positive or negative. So if it has a positive correlation, the R value is positive. If it has a negative correlation, the R value is negative. And the closer that they are to being on a straight line, the closer they are to 1 or negative 1. Okay? So if all of my points fell on a straight line, they all fell right here, that would be a positive 1 for my R value, because it's a positive correlation and they would be on a straight line. Now this one is probably more like a 0.8 something, 0.8. It's positive, it's close to 1. At 0, that means that there's no correlation whatsoever. It's just scattered all over the place. You can't tell what the correlation is. Okay? So the closer you are to positive 1, that means the points are closer to a single line, and it's in the positive direction. The closer you are to negative 1, the closer they are to a single line in the negative direction. Okay? So looking at, whoops, nope, I'm right here. Oops, too far. Okay. So looking at this one, I'm going to give you 1 minute to choose where you think they should go. Quietly. All right. Without doing anything, which two would you say are closest to falling on a straight line? These two. Is this one positive or negative? Positive. So which one of these R values matches it?
0.43.
That's a negative. 0.14 is negative. It's the 0.8. It's close. These are close to being on a single line, so it's close to positive 1.
Oh.
You see what I'm saying?
Oh, I just didn't understand.
Okay, positive direction, close to a straight line, so it's close to a positive 1.
Yeah, that's what I have on here.
Okay. This one is close, the other one that's close to a straight line, but it's in the negative direction. So which one would that go with?
Negative 76.
Negative 0.76, because it's going to be closer to a negative 1. Does that make sense? These that are farther away are not as close to a straight line. Do you see that? Now, this one, would you say this has a positive or a negative correlation? Positive correlation. And so we would say that one has to be the 0.43.
Okay, now it all makes sense.
Good, good. This one, we would say has a negative correlation, but these that are out here kind of scattered, like this is where it looks like they should be, but we have these scattered points. So since they pull it farther away from a straight line, that's why it's so far away from negative 1. You see what I'm saying? You can tell it has a negative correlation, but these points are very scattered. With me on that? Those are easy, like, oh, I haven't learned that before, but I do get it now. Are we okay? All right, the fun ones. You guys get to look at the constructed response that was on the released test. So on the actual post-test that we took, I had 2 people who got this right out of everybody. 2 people out of all Algebra 1, just so that we're clear. So Tony moved to a new house and wants to install a pool and landscape the yard. He will hire a company to manage the landscaping. Tony is considering hiring Company A or Company B. Company A and Company B's landscaping costs are shown in the tables below. Tony is reseeding the front lawn. The lawn covers 2,500 square feet, and the grass seed is $15.98 for each 7-pound bag. Each pound of grass seed covers 150 square feet. How much will it cost to reseed the lawn? Show all work. Enter the cost and work in the box. Okay.
I have a question on this part. Okay, so when it asks for the cost, do we have to include the cost for just the grass seed by itself? Okay.
We have 2 minutes. Right.
What?
I said we have 2 minutes.
2 minutes? No, we're doing this together.
Right.
Oh, did you?
No, right.
I can't tell you that.
I can't come back.
Okay, no. All right. I want to be able to show my work here.
Yeah, I didn't understand this.
Oh, now. All right. So, it says Tony is reseeding the front lawn. The lawn covers 2,500 square feet. The seed is, well, what the heck? $15.98 for a 7-pound bag. Each pound of grass seed, so 1 pound, covers 150 square feet. Yep. Oh, no, triple. Those won't work. Oh.
I'll see how many.
Thank you. So the first thing I want to do is determine how many pounds of grass seed it's going to take to cover this space. Okay? So I have 2,500 square feet of lawn. 1 pound covers 150 square feet. So how many pounds will it take? How do I figure that out? Divide. So I'm going to take 2,500 divided by 150. What's that give me?
16.6 repeating.
16.6 repeating, all right. And then what I want to do, what is this? No, what does it represent? This was the lawn. This was 1 pound bag.
Oh, that's how many bags it's gonna take basically. But
Okay.
That's how many pounds.
This is how many. This is a 1 pound. How much 1 pound covers? So this is.
pounds, 16.
It's going to take 16 pounds, which is how many bags?
Oh wait.
16 divided by 7.
16 divided by 7. Sure. Okay. So what's that give us?
2.
Mm-hmm.
It's 2.2857142857.
Okay. So take that times the cost of a bag.
How much is it?
It's 15. Sorry, it's $15.98. So I have to have 3 regardless.
44.
So you need to take 3 times that value probably. What do you get though? Tell me what you get.
36.5257142855.
36 point what?
0.525.
36.525. Okay, so this is just for the seed. I want you to understand that. That's what the seed would cost. All right. So on part A, it says write an equation to model what it would cost if company A was hired. Enter the correct equation in the box. Okay, so company A, let's do. There. Okay, so for company A, we know that for 300 square feet they charge $7.50. For 980 square feet they charge $24.50. Blah 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 all the way through, right? From this information, I would like to determine how much they charge for every single square foot. That way I can just figure out how much it's going to be for this 2,500 square foot lawn. Okay? So the way I can do that is by taking x1, y1, and x2, y2, and solving for the slope, because that's the rate of change, right? So this is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So on y sub 2, what is that?
7.
Y sub 2.
$24.
$24.50 minus y sub 1 is $7.50, right? Over x sub 2, which is $9.80 minus $300. So what's $24.50 minus $7.50? Gage, pay attention. Put that away, please. Thanks. What is $24.50 minus $7.50? You all have calculators. Let's go. 17 over 980 minus 300. 680 all by. And then what's 17 divided by 680? Just 0.25?
No, it's 0.02.
0.025, yeah? So this is my slope. So to figure out how much this company is going to charge me, all I have to do is say the cost is equal to 0.025 times the number of square feet. Does that make sense? So if the lawn is 2,500 square feet, what does it cost? $62.50? Everybody with me on that? We found the slope. That's all we did with this. Looks complicated, sounds complicated. We found the slope. We plugged in 2,500 to find how much it would cost if we went with company A. So write an equation to model what it would cost. This is your equation. And that's all you don't even have to do this part yet. This is all you have to put for this part. Okay, so the next part of it is part B. And it says to write an equation what it would be for company B. So the exact same concept, only you're trying to figure out the same information for company B. So right now, on your own, I want you to do what we just did for company B. Go. Okay, so we need to do the exact same thing we just did. So tell me what you started out by doing. X sub 1, x sub 2, x sub 1, y sub 1, x sub 2, y sub 2. It's not squared. If you say squared, you're likely to square it in the equation, and then that's going to ruin your answer. You're not squaring anything. It's just saying first one, second one. You said squared. Don't say squared. It doesn't mean the same thing. So m equals y sub 2 in this case is 2350 over. Okay. So what did I get, or what did you get rather, when you did this? Say it again for me. 0.015. Okay, let me just a second here. Okay. So m is okay, and on this one, they don't tell you this, but there is actually a given cost with company B. So whenever you do it, you have y minus y1 equals m times the quantity of x minus x1. This is your m, but you need to plug in this first point to determine what you're adding for your y-intercept, or for the the flat rate that they charge. So we have y minus y1 was 16 equals 0.015 times x minus, what's x1? 400. So when I simplify this, I have y minus 16 equals 0.015 x, what's that times 400? 0.015 times negative 400. Negative 6. And then to get y by itself, add 16 to both sides. So you have y equals 0.015 x plus 10. So the only thing is that they tell you they want you to use C and S. So you have to be careful about that too. So the cost is equal to 0.015 S plus 10. So how much would it cost to do the yard if you chose company B? What are you going to do to figure that out? Multiply. So do it.
How many does it say? How many yards?
It's for 2,500 square feet. 4750. So the cost is 4750 for company B. What was it for company 1? What do we say? Whoops. 6250. Okay, so the next part of this, I think the last part of this actually, says, no, it's not the last part, part C. Which company would cost Tony the least amount? So which one would cost the least amount for his 2,500 square foot yard? Company A or Company B? Company B. Okay, explain your answer. So how would you explain your answer? Because you pay less. I need more specifics. So Company A would cost 62, huh? Right, so you want to be specific. It would cost $62.50 for company A, company B is 47, blah, blah, blah. You'd be saving this much money. You want to be specific. Complete sentences and as much information as possible. Okay, so number 3 on this says, how many square feet will both companies cost the same amount? So we had the, why does it do that to me? The cost of company A was 0.025 S, right? Is that what it was? Okay, and the cost of company B was 0.015 S plus 10. Okay, if I want to know where they cost the same, what do I want to do? Set them equal. Company A equals company B. So I have 0.025 S equals 0.015 S plus 10. What should I do? I'm not combining like terms because I would be doing that on one side of the equal sign. This doesn't have anything to simplify. And this side, I don't have any like terms, right? So I'm not combining like terms.
You're subtracting 0.015 S
From each side, right? 0.015 S from both sides. So what's that give me? 0.01 S. How do I get S by itself?
divide.
So I'm going to divide by 0.01 on both sides. And what's that give me? 1,000. So they cost the same if your yard is 1,000 square feet. So if you had less than 1,000 square feet, company A is probably the choice for you. But company B, after you get past 1,000, is cheaper. You see what I'm saying? Okay, and the last one says, Tony is installing a rectangular pool in the backyard. I'm going to copy this one over. Okay, Tony is installing a rectangular pool in the backyard. The pool needs to have a length of 10 feet more than the width. The backyard is a square shape with each of its sides measuring 5 feet more than 3 times the width of the pool. Write an expression for the area surrounding the pool after the pool is installed. Show your work, blah, 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 blah. Okay, so the first thing I would do is I would start drawing myself a picture of this, okay? So I know that he's installing a rectangular pool. So draw yourself a rectangle. Rectangle. How many triangular pools have you ever seen? The pool needs to have a length of 10 feet more than the width. So the width of the pool, the length needs to be the width plus 10. You with me on that?
Yes.
10 feet more than the width. Okay. The backyard is a square shape. So inside of the backyard it's a square. And it says that each of the sides measures 5 feet more than 3 times the width. So 3 times the width plus 5. Are you with me on that? That's the side length. 3 times the width plus 5. Does anybody not know where we got that from? Everyone does know where we got it from? Okay. So it says, write an expression for the area surrounding the pool. So that's this area surrounding the pool after it's been installed. So the first thing I have to do is find the area of the pool. Okay, so let's do that first. So the area of the pool. How would I find the area of this pool? Length times width, that's right. So the length is W plus 10. The width is W. So what should I do? This is the length. W plus 10 is the length. I want to distribute this, right? I'm just simplifying it. It's not going to be a concrete answer. So the area of the pool is equal to, what's W times W? What's 10 times W? Okay, so this is the area of the pool. What's the area of the yard? 3W plus 5 times 3W plus 5. I would have to FOIL this. And then once I have that, I take the area of the yard minus the area of the pool. Okay, that's all I've got for you.